we were just wondering
How do you think 3D glasses work?
when you see without them, you can see that there are different layers behind each film. Like there's the green and the green. Okay. Well, there are different colors that you can see. So I'm assuming there are different layers behind them, and then 3D glasses have those layers that translate it.
Well, I'm pretty sure it's all about the lens and production technology. When you go to the movie theater, there's normal and then there's 3D, right? So like, there's obviously something different about the thing. It's not really the glasses either. They have to include something in the machinery to.
So the projectors?
Yeah.
Okay.
I think 3D glasses work with your eye, how the way your eye sees the light rays. So basically, 3D glasses are made of a material or different colors, so that your eye sees the 3D images differently and they appear on the screen.
So basically, when you're looking at it, right, there's like light hitting you, right, and then there's like this magic that happens, which allows you to see it in 3D, right?
Magic.
Yeah, and so could you elaborate more?
Magical unicorns come and bless your 3D glasses, enabling them.
I honestly don't know. Maybe like the red and the blue contrast, they create a 3D image.
I think 3D glasses work. I don't know.
Magic was a popular answer, which worried us. People were on the right track, but were still confused and unsure. So we decided to relate 3D glasses to a more commonly used tool in everyday life, the eye.
So how do you think our eyes see depth? How do we observe what's further and what's closer? Honestly, I have no clue. Why do you think our eyes are in two different places? Why would that be? Oh, okay. So, I mean, I don't know why, but whenever you do the single eyeball test, okay, your depth of perception means it's not as good as it would be with two eyes. One eye would be focusing on this point, whereas this eye would be focusing so that they both meet somewhere. Knowing how our eyes work, how do you think that relates to 3D glasses working? So I'm assuming the glasses themselves have the same layers as the film, and then that the frames, once they match, not exactly the frame itself, but the layers of the frame, the way the colors work. Okay. I'm assuming once they match, they work, and then they give you the 3D effect.
There are many different types of 3D glasses. Anaglyph images were invented in 1853 by Wilhelm Roman. The lenses in anaglyph 3D glasses were typically red and green, until the 1970s when manufacturers began using red and cyan lenses. They produced. First, if some color from the left image gets into the right eye, and vice versa, a faded colored image will appear. Second, if the brightness of the two images is not the same in each eye, the effect is unpleasant, and often the image will flicker. Last, since each eye is getting only part of the RGB color range, the color viewed will always be off. Passive 3D glasses were invented to resolve these issues. They are commonly used in movie theaters and function by restricting the amount of light that goes into each eye, therefore reducing the glare. They were invented by Edward Lynn and have been brought to films in 1936.
Here is a ray diagram of light traveling from a projector to 3D glasses. As you can see, light travels from this projector to the screen, where a condenser lens with a diffuser film helps light reflect to the corresponding polarized lens of the viewer's 3D glasses. In this process, the light from the screen is circularly polarized. Once it propagates and reaches the 3D glasses, this light is converted to linearly polarized light. From here, the image is seen in a different perspective in each lens due to parallax. Parallax is the apparent displacement of an observed object due to a change in position of the observer. Your brain helps create one stereoscopic 3D image from the two different images viewed in each of the lenses of the glasses.
Parallax? What's a parallax? Those were a lot of big words, and it was pretty hard to understand. I didn't get much of it either, so how about we try an experiment to better understand this concept? So here I have two passive 3D glasses. So what we're going to do is look through one of the glasses and observe what we see in the other glass. So this is the left lens of the first passive 3D glasses, And do you notice anything different about the other glasses? This is without the lens. This is with the lens. The left side seems to be a bit darker. That's because the left lens is polarized in a way which it's polarized the same way as the right lens of the other glass. And that means light passes through without a problem. But the dark side, it's polarized the opposite way. So this creates this dark effect. And the same thing with the other side of this lens. Now it switches. That's because this lens is polarized the same way as the light side and the opposite way of the dark side.
Plastic 3D glasses are made from polymer film lenses, while also the outside being plastic. Therefore, it's really environmentally friendly, while also recyclable. For example, when you're done your 3D movie, usually dump your plastic 3D glasses into a recyclable bin. Also, polymer lenses is not really a rare material, therefore it's really cheap. 3D glasses are becoming very popular and a part of the North American culture because they're very cheap. They're also a part of many home theaters systems and also movies we watch at the cinemas.